Hello, now it's time for monitoring, which could even be the most important thing covered in this course. Why would that be the case? Well, if you don't have a proper monitoring established, then you should not use Kafka on production at all. There are many things that can go wrong, and monitoring is the way to either prevent any issues from happening in the first place, or if they do happen, then to be able to react as fast as possible. So do yourself a favor and use Datadog or any other similar tool and establish monitoring for some critical things. We are going to monitor three kinds of things, or actually two. The first one being the Kafka cluster itself, and the other two being applications, so producers and consumers. It's important to keep in mind that both brokers and applications metrics are critical, as they are going to help monitor different things, although some really bad things happening on the broker level will be reflected in the applications metrics as well, or rather consumers and producers metrics. Kafka uses Kafka under the hood, at least in version 1, and Kafka has an awesome integration with Datadog, so that makes things quite straightforward. Let's start then with broker metrics. The first one will be under replicated partitions. So basically you want to make sure that it stays the way as it's shown on this graph. It's not always obvious what could be the cause of having under-replicated partitions. It could be some of the brokers being offline, maybe there is some hardware problem, or could be even sometimes a huge performance issues. Regardless of that, anything different than 0 here needs to be immediately looked into. Active controller count. There can be only one broker in charge, no exceptions. If it's not one, it's a sign of the issue. There are two brokers saying that they are the controller, and probably one of them got stuck somehow. And if it's 0, it will be reflected in other metrics, as this would probably mean that there is a serious issue with the cluster. Messages in per second is quite self-explanatory. If there are events published regularly, you definitely don't want to see it going to 0, as this would indicate a problem with producers or the broker. You could also follow some patterns of growth rate here, or perhaps look for some serious imbalance between brokers. A very similar one to the previous metric, this time it's not in terms of number of messages but the size. And the counter metric for the consumers, bytes out per second. If something is getting published and this goes to 0, then there is a problem. Funny enough, there are no messages out per second, as this is how things work internally in Kafka. Leader count metric is important to watch out for to make sure that the distribution of the partitions is even between brokers. Offline partition count is a critical one. This absolutely needs to stay at 0. If it's greater than 0, then perhaps some brokers are down. Replication Max Lag is quite self-explanatory, and you probably want to have 0 all the way here, just like for the databases. If you don't have size-based retention configured, this is something you definitely want to watch out for, as running out of storage is a pretty catastrophic scenario. So that would be it for broker metrics, and let's move to applications metrics. And first, let's go with the producer ones. API calls indicate whether stuff is happening or not, so it probably shouldn't go to low or 0 unless it's expected for some reason that during some period no events will be published. It's worth watching out for some anomalies and patterns and establish the proper monitoring for them. Deliver messages metric is very close to the API calls, and the visual correlation is also apparent here. At least it should be that way when everything is just fine. And deliver attempts should be close to 1-to-1 with deliver messages. Anything different than that would indicate a problem. Deliver errors quite self-explanatory. Ideally, it should be 0 all the time. And that would be everything for producers metrics, so let's take a look at the metrics on the consumers side. So again, API calls. If consumers aren't down, it shouldn't fall to 0. And again, if it's worth setting up some monitoring for anomalies. The interesting thing here is that there is some sort of imbalance between brokers on this graph, but it's hard to tell if it's legit or not. Something to be investigated further, as it's not really so black and white with these anomalies. As far as API errors go, we should also have it 0 all the way on both consumers and producer side. Perhaps the most critical metric on the consumer side, a lag grouped by topic and partition. So if it's 0, then it's perfect. your consumers are super fast, everything is processed, and there's not much delay between something happening somewhere and the consumer reacting to it. But that won't be probably always the case. Like in this graph, for close to 10 minutes after 4 am, the curve sharply increased and then decreased, suggesting that there was a lag for a while, creating some delay. And later, after 4:15, there was some lag as well. Depending on the logic of the consumers and your expectations, this could be either okay or not. If it's not, then it would be a good time to think about some performance optimization on the consumer side. And guess what? I recorded a dedicated episode for it. Consumer messages is another important metric as it shows how messages are distributed over topics and partitions and what is going on in general. And clearly here there is a way higher traffic in some partitions comparing to another ones. Whether it's a problem or not, it highly depends on the specific use case and what is really expected. However, imbalances between topics are something different than imbalances between partitions. If there are indeed imbalances between partitions in the same topic, it's something worth looking into. Consumer leave is a pretty important metric and usually it's worth looking at it together with 3 other metrics: consumer sync group, consumer join group, and fetcher queue size. Having something registered in leave group means that the consumers were leaving the consumer group and it's usually correlated with deployments and restarts. Sync group is also correlated with deployments, however, it also happens when there is some instability with processing messages by consumers. It usually happens when there are some errors in the logic or the processing is slow. And in such case, there is usually a correlation with consumer join group metric and fetcher queue size. This metric is registered when a consumer is assigned with a partition. Like I mentioned, consumer join group is very similar to sync group. This metric is registered when a consumer joins the consumer group and having something registered without any deployments, restart, and similar things is a sign of the problem. This metric is super important to watch out for. Without going into implementation details, the rule of thumb should be that its value shouldn't be anywhere close the maximum specified value for too long. By default in Kafka it's 10, but you can configure it. If it's often at the maximum value or close to it, then the consumers are basically too slow. Quite often it happens that some database index is missing when performing some query and it shows as an increase in the fetcher queue size metric. And when there is some problem here, you will often see it together with sync group and leave group. And that will be everything as far as monitoring goes. And again, don't try to use Kafka on production without proper monitoring. And see you in the next part that will be about consumers and improving their performance.